Hello student, welcome to this lecture. Today we will discuss the measurement system of the length, how we measure the length. In the last class we discussed the measurement systems and the unit, but in this class we will learn how we will measure the length. Okay, so let's start the session. So first of all, I will introduce you some units, okay, which we use in the length measurement. So here I will represent some units like Fermi, which is in the range of 10 to the power minus 15, angstrom, 1 angstrom, it is in the range of 10 to the power minus 10 meter. Similarly, 1 astronomical unit, which is a roughly calculated average distance between the sun and earth. Okay, similarly, light year means it is the distance, okay, traveled by the light in 1 year in vacuum is called 1 light year. And 1 per second is also a distance, okay, which 1 astronomical unit sustain an angle of 1 arc second. So these units we use for different measurement of the length. Fermi and angstrom, which are the units which required to measure the small length, very small length. In case of when you measure the radius of atoms, okay, and protons, neutrons, then you use Fermi and the angstrom. But when you measure the distance between the planets, you can use astronomical unit and light year. Okay. So next, measurement of the length. In measurement of the length, we use some measuring tools like screw gauge, slide caliper, and the meter scale. Meter scale is basically used to measure the length. If you draw a straight line, then you can measure the length of this straight line by the meter scale, and you also can measure the length of a table by using the meter tape. But the slide caliper and screw gauge are used to measure the radius of a sphere. Okay, and by helping the slide caliper, you also can measure the inner radius of a ring. But all these measurement tools are used to measure a specific range of length. But if you want to measure the height of a mountain and the distance between the two planets, or the distance of a planet from the earth, then how can you measure? Is there any measuring system available to measure these things or not? So many questions arises in our mind that how can we measure these things? So to measure these lengths, these very long length, we have a technique that is Parallax method. So we'll discuss about that. So before we going to the Parallax method, I want to give you one example, okay, and which help you to understand the Parallax method. Let's take an example. Here a black dot. Just take a pen, okay, and align that pen with the dot and try to get that dot by your left eye by closing the right eye like this. Okay, and after that just close your left eye and try to get the dot again by a right eye without disturbing the position of the pen. Okay, then what you found? Just think a little. You get any difference in that? Hope you will get some difference. That is, you found that the position of the dot will change when you observe from two different position or two different eye. This is basically happen because of the distance between the two eyes. Okay, and this is called the parallax method. It means the distance or the difference in the apparent position. When you look the dot from two different position, it gets two different position of the dot. You will found two different position of the dot. That distance is known as the parallax, and this method is known as the parallax method. So by using this method, we can calculate the large distance. It means the distance between two planets, okay, and distance between the sun and earth. So before calculating the distance of a planet from earth, just look at the figure, that how the position of our near object change with respect to the far object. Here a car is moving, okay, and the trees which is just near to that car changes when car travels, but the far object, that is the background figure is remain constant. So when you travel from one point to another point, you will get that the position of the near object changes with respect to the far object. We will calculate the distance between nearby star on the earth. So to calculate this distance, we have to consider some distant star and sun. When in the month of the December, earth is at a position, okay, after 6 months it will change its position, and it is given by the month June. And when we look the star, okay, the far star from two different observation point, that is when the earth is at December and when the earth is at June, we will get two different position of the star. Here a small example is given, that when you view from the viewpoint A, you will get that the star is at blue position, but when you view the star from the point B, you will get that the star is at a red position. So you will get two different position of the star when you see the star from two different viewpoint. So here the angle between the different two viewpoint is known as the parallax angle. I mean that here it is given by the theta. So once we know the value of the theta, parallax angle, and the distance between the sun and earth, we can calculate the distance between the sun and the star, the nearby star. So here just a simplified diagram, that it looks like a triangle, right angle triangle. So by putting the trigonometric formula, we can calculate the distance d. Here if we put the trigonometric formula, that is tan theta equal to that the perpendicular distance by the base distance. Here the perpendicular distance means the distance between the sun and earth, and it is already calculated, that is it is equal to the 1 astronomical unit. I already told you that 1 astronomical unit means the distance between the sun and earth, and it is average distance between that sun and earth. It is not the exact distance, okay. So here we will put that distance, that is tan theta equal to 1 AU by D. But here another example, here another formula is also there, that is theta equal to 1 astronomical unit by D. But just remember that theta in radian. If theta is in radian, then you put theta equal to 1 astronomical unit by D. But why we use this formula? Because we already have a formula like tan theta equal to 1 AU by D, okay. So when the distance between the sun and the star, or the earth and the star, is very long, then we observe that it is like a sphere, it is like a circle with center at the star, okay. That's why we got a section of a circle. So we put theta equal to 1 AU by 1 astronomical unit by the base distance. So from this we can calculate d equal to 1 AU by theta. So if we consider the position of the planet is the S and the distance from the two viewpoint is d, the distance between the sun and earth is d, and the parallax angle is theta. For a very away planet, the planet which is situated at very far distance, AB, the distance between the planet, distance between the earth and sun is behave like an arc. So we put the arc formula, which I already told you that how we will calculate the radius by using the arc and the theta. So you can simply calculate the distance of a planet from earth by just putting the simple trigonometric formula by using the parallax method. So similarly, if we want to measure the height of a mountain, then how can we measure? We will put here also the same trigonometric formula, that first we will observe the tip of the mountain from a point here I have given, that is B, okay, and the angle is alpha 1, and after just by moving some distance d at point C, again we will observe the tip of the mountain, and we again measure the angle, that is alpha 2. It means once you got alpha 1 and alpha 2 and the distance d, you can calculate the height of the mountain h and the distance x. It means the distance between the mountain and you. So it is just simply you put the trigonometric formula what I told you in the previous slide. And here some ranges of the some range and the order of the length are given.